Long, long ago, when the earth was still of its natural and untimely beauty, primitive mindsets were the dominant and existing call upon which different species struggle for its survival. Few years after, community structure changes. Its horizontal and vertical progression led to the huge diversity among individuals, of which the ones who survived are naturally selected, as termed by Charles Darwin, the proponent of the theory of evolution. Community dynamics is dominated by succession, the origin of dynamic ecology. Primary succession occurs on newly exposed substrate. Secondary succession occurs after disturbances. These are the concepts that could somehow expound how the community changes over geological time. Different theories, views, and models were proposed by different scientists and ecologists regarding the pattern of species and, most importantly, succession. Despite the differences of these theories, similarities arise in the way that each contributed to science, and each of these theories undermine change. What is change? It is something that makes constant things seem temporary. It is something that makes organisms adapt, fight, and compete to survive. It is the only thing that's constant. Different theories, views, and models were proposed by different scientists and ecologists regarding the pattern of species and, most importantly, succession. Despite the differences of these theories, similarities arise in the way that each contributed to science, and each of these theories undermine change. What is change? It is something that makes constant things seem temporary. It is something that makes organisms adapt, fight, and compete to survive. It is the only thing that's constant.
Community structure varies in time and in space. The underlying principle behind community dynamics. In this dynamism, we ought to observe the gradual and seemingly directional change in community structure from field to forest. This process is known as succession.
The sequence of communities from grass to shrub to forest historically has been called a seer. Serial stages refer to the continuum of vegetation through time. Early and successional species show a pattern of colonization and replacement. With these concepts in mind, community dynamics emerge. Primary succession occurs on newly exposed substrate. Imagine a sand dune deposited by wind and water. From there, grasses begin to emerge and stabilize the dunes. Mat-forming shrubs starts to dominate, and vegetation give rise to trees that are favorable in the environment. Because trees shade the soil and accumulates litter on the surface, it improves nutrients and moisture conditions. This scenario emphasizes the colonizing species that enhances the environment, giving way to innovation of other species. Secondary succession occurs after disturbances. A good example for this is the recovery of seagrass community. In a water system, rhizophytic macroalgae initially colonized a disturbed site. Their ability to stabilize sediment is fairly low, but their contribution to sedimentary particles occurs as they die and decompose. After a while, this causes algal densities to decline. Seagrass begin to invade the site, and their density starts to increase in their early successional stage. Through time, later successional species colonize the given site at a slower growing pace that cause seagrasses to decline. Slowly, the buildup of organic matter on the sediments starts to increase, eventually transforming the once disturbed area to resemble again the surrounding seagrass community.
The study of succession has a rich history. One of the hypotheses created during the early times is the monoclimax hypothesis by Frederick Lemmens, wherein the community is viewed as a highly integrated superorganism, and the process of succession represents the gradual and progressive development of the community to the ultimate or climax state. It is often described as the origin of dynamic ecology.
According to Frank Eckler's view, the process of succession at any site is dependent on which species gets started first. so that it becomes more suitable for later succession species to invade and grow to maturity.
The acacia ant larvae live down hollowed-out thorns at the base of the acacia leaves. Some will eventually grow into adults and fly off to replicate this evolutionary masterpiece in new acacia.
The inhibition model involves strong competitive interactions. No one species is completely superior to another. Pioneer species inhibits the establishment of other species. As long as it lives and reproduces, the first species maintains its position. The species relinquishes it only when it is damaged or dies, releasing space to another species. The tolerance model shows that the later successional species are neither inhibited nor aided by species of previous stages. They can invade a newly exposed site, establish themselves, and grow maturity independently of the species that follow them. They tolerate lower level of some resources.
There are two general classes of environmental conditions that bring about the shifts in the physical and biological structures of communities across the landscape.
The direct result of the presence and activities of organisms within the community is known in an autogenic environmental change. It is a change due to some externally imposed environmental change. It is more common in plant succession. Allogenic environmental change is different from physical rather than biological processes. Shading by development of a tree canopy and accumulation of liquid could serve as an example.
Poesia.
Patterns of species diversity changes over the course of succession. Colonization by new species increases local species richness, while replacement, over time, acts to decrease species richness. During early phases of succession, new species that colonize the site causes an increase in diversity. However, through time, species become displaced by slower growing, more shade tolerant species, making the earlier species diversity to decline. Peaks in diversity corresponds to a transition phase between early and later stages of succession. Patterns of diversity during succession are influenced by resource availability and disturbances.
By early March, bears begin to emerge from their long winter's nap. seem to think they can take it. The Haydens prove to be more than the young bear can handle. This time.
It's like suiting up for battle, which may sound extreme, but it's terrible.
Each one of these stems will need to be injected. So you can see there's about 6 stems there. And the machine is some rhizomes underneath the ground. You can see the roots coming out a little bit there. So by hitting each plant, then you can ensure that they'll stay dead. By leaving one plant, then they will be able to reproduce. I've seen patches that are mowed down to the ground, and within 2 weeks they're tall.
Japanese knotweed. It quickly takes over, killing off native plants and dominating stream banks. The Invasive Species Council has spent several hours treating 3 huge patches of knotweed in this North Vancouver District Park.
We've been going for 2 months now.
This week, the council is asking Metro Vancouver for funding and resources to develop a regional strategy. The sooner the better. Invasive species aren't just a nuisance. Knotweed can grow through concrete, destroying infrastructure in the process. So even with the crew working as fast as they can, it's just a matter of time before that happens here.
Succession also includes heterotrophic species. Associated changes in the heterotrophic component occurs as plant succession advances. This is brought about by the changes in the structure and composition of the vegetation that the animals depend on.
Successional stages of animal life may not correspond to stages identified by ecologists. In plant succession, animals can quickly lose their habitat as the vegetation changes. This could be further explained by imagining an old field becoming a conifer forest, which underwent vegetation density and height change. As a result, this affects the appearance and the disappearance of species in the place.
In the early stages of succession, old fields supports meadow larks, grasshoppers, and meadow mice. When moody plants invade, a new structure appears. With this, the previous species soon disappear and is replaced by shrubland animals such as catbirds, goldfinches, and white-footed mice. Further changes happen as woody plant growth proceeds and the canopy closes. Shrubland species are now replaced by birds and insects of a forest canopy. As this proceeds, the vertical structure becomes even more complex and species such as woodpeckers, tree squirrels, and birds appear. Although the focus on succession has been on shifting patterns of community structure in response to autogenic changes in environmental conditions, these abiotic environmental changes can produce patterns of succession over timescales. Shifts in the environment conditions that occur at periods as long as or longer than the organism's lifespan are likely to result in the successional shifts in species dominance. The structure of the earth has changed and is still continually changing over time. the Earth's land masses were not the same as it is today. Continents which formed as the Earth's plates shifted and collided over a long span of time. Formation of mountains have occurred as well as the rising and falling of oceans. These are the changes that affected the Earth's climate as well as other conditions of the environment. This in turn affected the population of species on Earth.
Animals and plants have adapted and evolved, and those that were not able to became extinct. Evidence of the presence of these organisms that once roamed the Earth is present in fossils. This can be further studied in paleoecology, which is the study of ancient plants and animals and their relationship to the environment.
Currently, climate change plays an important role in the changing of Earth's structure. An example of the effect of this phenomenon would be the drastic melting of ice in the North and South Pole, which contributes to the rise of sea level.
Wall of ice, 1,000 freshwater cascades plummet into the sea. As July draws on, the great melt reaches its peak. The greatest seasonal change on the planet has taken place. The sea ice that once extended all the way to the horizon is now open ocean. In just 3 months, the sun has won its battle with the ice. Over 2.5 million square miles of ice has melted away, uncovering thousands of islands surrounded by open ocean. But in recent years, the scale of this melt has been growing. And for one animal, this is a critical issue.
The community is viewed in two contrasting concepts. According to Frederick Clements, the community is a quasi-organism made up of interdependent species. In contrast to this, Gleason saw the community as an arbitrary concept in which organisms respond independently. The reality is that the viewpoints are affected by our perspective. The community is a spatial concept, whereas the individual continuum is a population concept.
But there are little ticks to be had in the various cracks and crannies, and oxpeckers go there to search for them.
What we witnessed are the scientific facts that we should know and the truth that we ought to know. Everything changes, may it be for the better or for the worse. Which change are you on?